course, so I'm not going to erase it, but I'm just going to go back through it. But basically, when you're solving equations, basically to undo a problem, basically to solve for x, you have to undo the problem. So we look at this first one. We have e to the x equals 2.3. Well, to get rid of the e, to get x by itself on one side, we take its opposite, or its corresponding partner, which is ln. So if we take the ln of both sides, we realize that the ln of e equals 1, and it basically leaves it with just x on the left side. And since it's an equation, we do the same thing to both sides. So that means we'll take the ln of 2.3, which is about 0.833. If we look at b, we have the ln of x equals negative 1.5. To undo the ln, to get the x by itself, we have to put e on both sides and then raise the ln of x to e and raise negative 1.5 to e. Because the ln of e, again, it cancels out, leaving you with just x on the left and then e to the negative 1.5 on the right, which when we type in our calculator, we get 0.223. Over here, we have 10 raised to the x equals a 0.75. Well, to get rid of the 10, to get the x out of the exponent, we take the log of both sides, because a log that doesn't have a base written is log with a base of 10. And log base 10 of 10 cancels out, because those were the properties that we talked about last week, as you can see here. Okay, there it is. So then that leaves us with just x on the left and log of 0.75 on the right, which when we type into our calculator, we get a negative 0.125, rounded to 3 significant figures. All right, so for D, how do we get rid of the log? How do we get the x by itself? We can either write it in exponential form. Remember, any log we could write it in exponential form, so that could be the base, which is 10 to the third equals x, which is 1,000. Or what we could have done, if we kind of followed in the same features, we could have did 10 to the both sides. And 10 raised to the log with no base, which technically there's a 10 there. They cancel out, leaving you with just x equals 10 to the third. Either way, we still get the same answer of 1,000. Okay? Questions? Here we go. It says given that f of x equals 1/3 e to the 2x, find f to the negative 1 of x. So what does f to the negative 1 of x mean? The inverse. Okay, and so we'll go through the algebraic process here of doing inverse. So we know that this is y equals 1/3 e to the 2x. First thing we do algebraically to find the inverse is switch the x and the y. And now we solve for y. How do we get y by itself? How do we get rid of all this extra stuff that's with the y on the right side? Why do we multiply by 3? To get rid of the 1/3. So we'll have 3x equals e to the 2y. Now what? Take the natural log of both sides. Because the natural log does what? It cancels out the e. So we have ln of 3x equals 2y. Divide by 2. And we'll have y by itself. We're not going to write y, we're going to write f to negative 1. And there's our inverse. So basically, we're just undoing that right side to get y by itself. We do the opposite. All right. So let's try this one. And on top of that, we're also going to state its domain. So I'll let you find the inverse first and see what you get. Okay. So similar to the last one. What do we do first here? What do we do first? I gotta switch first, and then natural log both sides, because the natural log is going to do what? It's going to get the e, get rid of the e, and bring down the 2y minus 1. Then it's just a little bit of algebra, right? What do we have to do? Add 1, and then divide by 2. And then, of course, remember our proper notation for inverse. Okay? Now for the domain. What do you guys think? 0 to infinity, would you guys agree?
For your own sake, just say yes.
No.
Maybe.
I don't understand.
Okay? Well, remember, when we talked about domains and ranges of exponentials and natural logs, okay? They're very similar to your regular exponential functions and your regular logs, okay? Realize that e to the x is just a particular, it's just a special type of exponential, okay? So here's your most basic one, okay? What is the domain of e to the x? It's all real numbers. What's the range?
0 to 0.
It's 0 to infinity, okay? Now realize that with inverses, what happens to the domains and ranges? They switch. So the domain of the original is the range of the inverse. And the range of the original is the domain of the inverse. Okay, so keep that in mind. So what was the range of e to the x?
0 to infinity.
So that would be technically your domain of your inverse. But there's just one thing that we have to be cautious of.
The movement.
The movement. Because when there is a minus 1 inside of the exponent, that means it moves which way? It means it moved to the right one. Now, if I move to the right one, did that change my my range of my original? No, it didn't. It didn't even change my domain because my domain is all real numbers. So the domain of this is all real numbers, and the range is 0 to infinity. Because all it did was just move to the right and get stretched a little bit. But that wouldn't change anything. So then the domain of this would be what? 0 to infinity. Okay? I have another one. We got about 3 more of these, okay? So I want you guys to get comfortable with finding the domain range of these inverse functions, okay? So here's the next one. This time we're finding the domain and range of the inverse. Uh-huh.
And then we added the natural log.
Uh-huh.
And then we divided by 0.25, so we have natural log x over 0.25 equals
Okay, so you found the inverse. Okay, now you have to find, so we have to state the domain and range of the inverse. Okay? So how do we do that? Since you guys found the inverse. I'm guessing that's what you guys do, right? Okay. You have to do that?
No.
No, you didn't have to do that. Because all we needed is just the domain and range. Don't worry, we'll make sense. Everybody else. Domain and range. That restriction right there, that -2, x is less than or equal to x, less than or equal to 4, what is that? What does that represent? No, not an asymptote. The domain of your original function. So this right here represented the domain of f of x, which means that -2 to 4 would be your what?
So that's in the original range.
That's it. Just switches to a rating.
Because everything about inverse functions switches. The x and y switches, which means also your domains and
So
ranges.
that's the domain of the original with range of the
Inverse. Now, how would we find the range of the original function? Plug in -2 and -4. So to find the range of the original function, which would technically be our domain, of our inverse, we plug in. So f of -2 and f of 4. Because these are the x's, we just need to find their corresponding y's. So when I plug in -2, what's a quarter of -2? It would be -0.5, so we have e to the -0.5. And what about when I plug in 4? What's a quarter of 4? So my range of my original function is this, which means it's the what of the inverse?
Rewrite the decimal to something like that.
You can look like this. So remember, everything switches. So if you can figure out what your domain and range of your original are, you know the domain and range of your inverse. So the orange is your answer. Question?
I understand when you put it right in, how did you get
Because when you plug in -2 here, so this is basically 1/4 times -2, which is just e to the -1/2. That's where that -0.5 came from. Okay, so that would be the y coordinate for x is -2. You do the same thing for +4, and you get e to the first. And that's the corresponding y's that go along with the x's. Okay? Get 2 more. Make sure you read so you know what you're looking for. Okay?
We can find the range now? Oh, no, they did that. My bad, my bad.
Alright. Here we go. Here's the next one. Okay, so what are we looking for in this problem? The inverse. So first thing we need to do is switch, then raise. And why do I raise? To get rid of that. So I have e to the x equals 3y.
They're gonna get complicated and longer.
I like the other way better. She says.
I like this better than what we did. Yeah, but it can't be this simple.
It's not me. It's kind of fair. Style the basis. Here we go. Here's the next one. Okay, so we have given f of x and g of x, and we have to find g of f of x. So that means we have to plug in f into g. So this is what you should have had. Okay? Now, using our properties here, what happens? E and ln cancel out, leaving you with an x minus 1. So you can have 2x minus 2. That's it. You don't have to solve anything here because it's not saying, if it said equal 4, then you would set this equal to 4 and solve for x. If it said something like this, then you would plug in 4.
That's what I meant.
But it didn't ask for any of that, it just asked for
Like it just means
the composite. I am. There we go. Few laws of logarithms. Okay, let's make sure we get these down. Here are your laws of logarithms. This is going to be helpful when it comes to solving logarithmic equations. It's also going to be helpful when they ask you to either condense or expand a logarithm. So you have log x plus log y. If you have the same base, this is key. You have to have the same base. It could be a base of 10, it could be a base of 2, but they have to have the same base. If you have the same base and you're adding 2 logs together, then technically you can write it as 1 log and just multiply your x and y together. Okay? Same concept, except this time when you're subtracting 2 logs, you're dividing x and y. Okay? So this could be like log of 3 minus log of 4. This would basically be the same thing as saying log of 3/4. Okay? Here, you have n times the log of x. Well, we can take that n and move it to the exponent and have log raised to log of x to the n. Okay? And also, this is kind of like one of those special laws, is that if you have a base 1 over x, remember 1 over x can be written as x to the negative 1. Y'all remember that? So then, as an exponent, remember it can be moved to the front using this law up here. Everybody see that? So, let's look at one. It says express log base 2 of 5 plus 1/2 log base 2 of 36 minus log base 2 of 10 as a single log. Now, there is a particular order in which you want to do these, okay? Of course, your order of operations applies, okay? So you have anything dealing with parentheses, then you don't want to make sure you do everything in the parentheses first before you apply anything on the outside. But more specifically to your laws of logarithms, the only way that you can ever, do the first two is if there's nothing in front of each one of the logs, okay? So if there's a log, or if there's a term that has a number in front of the log, like in this case here, you have to apply that power one first before you can ever apply the other ones. Does everybody understand that? Okay. So you have a log base 2 of 5 plus log base 2 of 36 to the 1/2 minus log base 2 of 10. Okay? So basically there cannot be a number in front of any of your logs to do either of the first two laws. Okay? Now before we keep going, what's 36 to the 1/2? 6. Because 1/2 is the same thing as the square root. Say log is 2 of 5, it's log is 2 of 6, it's log is 2 of 10. And then left to right. When you add, you can multiply. What numbers am I multiplying? 5 and 6 to get log base 2 of what? Careful.
Oh, about 30.
30.
I got my answers. I'll look over here.
And then we subtract. So this is going to be log base 2 of 3. Because you got 30 over 10, which is. And that's how you write that long expression as a single logarithm. Okay? Let's go the other way. Now we're going to expand. Okay? I think. Look at this. See, I had examples here. Let's do one more. Let's do this one. So what did you need to do first?
Transfer the 2.
Transfer the 2 up to be what?
Log the base of 10.
Log base 2 of what? 9. Then the correct order is going to be log base 2 of 54, because you got to multiply 6 and 9. And then log base 2 of 13.5.
27 over 2. Remember, she likes the fractions. She don't like decimals.
Just because.
Would you like 13.5 as a number ever? That's
I
just an
prefer it.
estimate. That's probably
I prefer most likely when you are dividing 27 by 2.
Alright.
But when you have no calculator.
Let's look at ones like this. These are more likely the ones that you would get on the IB exam. You would need what you are trying to write it in terms of log base 5, and then it is square root of x over y squared z cubed. What?
I don't think I understand.
I don't. No, now. This one I'm doing with you. The ones after this, you're gonna try on your own.
Is this a formula right here that we have to do or something?
Yes. Let me explain. Do you have it written down? That's the thing. I don't want to Anybody miss explanations that too busy writing it down? Okay. So basically what this is saying is that you're given that A equals log base 5 of x, B equals log base 5 of y, and Z equals log base 5 of z. You have to write this expression that's in the orange in terms of A, B, and C. Okay? So first off, you have this one expression. Okay? And basically what you have to do is you have to write it in terms of A, B, and C. Because you know A represents a particular log, B represents a different log, and C represents a different log from A and B. So, to write this in terms of A, B, and C, what you're going to need to do is you're going to need to basically expand this log right here. Okay? So let's start there. Don't worry about A's, B's, and C's just yet. Let's just expand this, okay? So what's the first thing that you think we're going to need to deal with? Question order.
Oh, this is for me to say.
Okay.
Would it be like you write log 5 square root of x minus log y log 5 squared and then plus log z?
Very good. Realize that when there's a division, that means you're basically subtracting two logs from each other. So this can be written like so. And then when you're multiplying, you're adding. So we need to expand here. Now be very careful. Isn't y squared and z squared being multiplied together in the denominator? So we got to make sure that when we read from left to right, it actually is showing that we're multiplying y squared and z cubed in the bottom together. So what do I need here? I need some parentheses. Okay? What do you mean? Yes, you would need to do that. So first off, does everybody understand how we got to this step? Okay. Now realize that every single one of these has an exponent, which means they can be moved to the front of every log. So it's like we're going backwards now. So realize that log base 5 of the square root of x is the same thing as saying x to the 1/2. So this is written as log, or 1/2 log base 5 of x minus 2 log base 5 of y, and then, careful, minus.
Oh, you distribute them at the same time.
Yeah.
Okay.
All right. Here we go. So we have this, which means that now what are we going to have to do? Distribute the negative. No, this is not in terms of A, B, and C. But this is expanded. So now with it being expanded, we should be able to write it in terms of A, B, and C. What does A represent? Log base 5 of x, which we have here, correct? So this whole thing can be written as A. So this is going to be 1/2 A. And then what is log base 5 of y? So this can be written as minus 2b. And what's log base 5 of z? Minus 3c. Now let's bring it in terms of A, B, and C. Yes?
I got you all the way there. Where did you pull the top one from?
What top one?
The very front thing at the start.
Yes?
Yeah.
That's
no,
it.
No, that, yes.
That was
This was the problem.
Oh,
That was
okay.
given to
And the thing was that I would have had to write it separated to type it in, so I was just like, I'm going to leave it blank and I'll write it in.
Oh, okay.
So that's the original problem.
That confused me from the beginning.
No, that's the original problem. So you expand, and then,
So whatever would be in front of log would be what A, B, and C was. So almost the exponents that were above were our A, B, and C.
no. Your A, B, and C are your log base 5 of x. There's everything without your exponents. The exponents were originally brought down using the laws, and then we were able to replace, hold on over there. So then we were able to replace log base 5 of x, log base 5 of y, and log base 5 of z, a, and c. Because that's on this side, hold up. We were able to replace them with those respective letters. Because that's what we were given in the very beginning.
Okay, I'm just seeing it the way that our exponents were in before. Okay, I get it.
Let's do another one. The last one you do before you go. You got it,